are going to dive into some trig ratios. Before we can really do the trig ratios, we do need to talk about the anatomy of a right triangle. So this right triangle has a 90 degrees marked inside the triangle. However, typically there is a little box in that section. The side across from the 90-degree angle is always the hypotenuse. So in this particular picture or image, the A is the angle in question. So the sides of the triangle have been labeled based off of that A. So we have our opposite of angle A and our adjacent to angle A. Just as a heads up though, I could be asking you about this angle. If I switch the angles, then the adjacent and the opposite will also switch. So now, in geometry, you probably saw something that looks a little bit like this. SOHCAHTOA. Now, when you were learning SOHCAHTOA, your teacher may have talked about hippies or even hags. No matter which way you remember it, you just got to make sure that you remember it. So when you were introduced to this in geometry, you started off with these three trig functions: sine, cosine, and tangent, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. This is where you started. Now we are going to add on to those. We're going to add cosecant, secant, and cotangent. Now these guys are all going to have relationships with each other. There is no coincidence that sine is across from cosecant, cosine is across from secant, tangent is across from cotangent. What happens when you go across is that the fractions reciprocate. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. Cotangent, adjacent over opposite. Now, there are some ways that you can remember this. The way that I like to remember it is that the S and C have to line up. So it's sine and cosecant, cosine and secant. The fractions are reciprocals of each other, meaning that the fractions just flip. Tangent and cotangent just kind of go together, so most students don't have any issues with those. Okay, let's start with this simple problem. So if you know that sine theta is 5/6, find the other 5 trig ratios. So before we dive into how we would answer this problem, I do want to highlight some vocabulary. Theta, let's not freak out about that. It's just pre-cal talk for angle, okay? So the sine of that angle is 5/6. So in order for us to really understand what's going on, we need a picture. So I'm going to put in a right triangle. It's not perfect, but it gets the job done. So here's my right angle. Let's say theta is down here. It doesn't matter where you put your theta. It's just for a sketch so you can understand. So I know that sine is opposite over hypotenuse. So opposite of the theta that I drew was 5 and 6. So we do have to figure out the missing side. To find this missing side, you're going to look for patterns. You can be looking for 30, 60, 90 triangles. You can be looking for 45, 45, 90 triangles. You can be even looking for Pythagorean triples. For this particular case, though, we don't have either. So we're going to have to use what we know about Pythagorean theorem. So I'm going to shift this over to the side a little bit so I can have a little bit of space. So Pythagorean theorem is c squared is equal to a squared plus b squared. My c is 6. A and B are interchangeable, so I'm going to say that's A. So I have 36 is equal to 25 plus B squared. So when I subtract the 25, solving for B, I get the square root of 11 is the missing side. So now I can use that information to find the missing trig functions. So the 6 trig functions, we have sine, cosine, tangent. This is where I want us to start, okay? So sine they give us, and I'm going to go ahead and write it in, and you'll understand why in a second. So I have sine is equal to 5/6. Cosine is adjacent over hypotenuse, so that's root 11/6. And tangent is opposite over hypotenuse, so it's 5/root 11. Now, taking a pause right here. You are not allowed to have square roots in denominators, ever. So we have to rationalize that denominator. So to rationalize the denominator, I'm going to multiply the numerator and the denominator by the square root of 11. When you multiply fractions, you multiply straight across. So I have 5 root 11 over 11, because the square root of 11 times the square root of 11, those roots cancel and just give you the radicand what's underneath. Other ways of thinking about it is that 11 times 11 is 121. The square root of 121 is 11. Doesn't matter to me how you think of it. Just make sure you remember square roots are never ever allowed in the denominator. So to come up with the other 3, remember that the S's and C's have to match. So sine is going to match with cosecant. Cosine is going to match with secant. Tangent is going to match with cotangent. So now from here, reciprocate those fractions. So since sine was 5 over 6, cosine 6 over 5. And the reciprocals just keep happening. So I'm going to reciprocate cosine. That one is going to be an issue because you're not allowed to have radicals on the bottom. You likely are going to get to a place where you can rationalize the denominator almost in your head. And if you get there, that's awesome. If you need to work it out, work it out. Okay? Cotangent, I need to reciprocate tangent. So that's going to be root 11 over 5. So notice that when I went to do the reciprocal for cotangent, I didn't reciprocate the rationalized denominator. I went back to the original. It's important that you do that, okay? So I'm not going to include this one or this one. So my final answer, find the other 5 trig ratios. I have 1, 2, 3, 4, 5. Next up, we need to start solving for potential pieces of the right triangle. So I'm asking us to find side B, side A, angle B. So what I'd like to start with is angle B. In geometry, you learned that there are 180 total degrees in a triangle. So if I subtract the angles that I know, which are 90 and 37, from that 180, I know that angle B is 53 degrees. Now, if you had more than one side length given to you, you could also use inverse trig functions to find the angle that way. Just be sure in your calculator that you're working in degree mode and not radian mode. Now, to find side B, I am going to use angle, let's say 37. To be honest with you, it doesn't matter if you use 37 or 53. I just like to use the angles that are given to me in pictures. So I now need to label this triangle according to angle 37. 8 is always going to be my hypotenuse. A is going to be opposite, and B is my adjacent. I'm never going to be able to mix the A and the B since I'm looking for them both. So I need to consider, okay, if I have A and 8, that is opposite and hypotenuse. So that is sine. So sine 37 is equal to A over 8. To undo that fraction, I am going to multiply both sides by 8. This is when you need your calculator, making sure again that it is in degree mode. If it's not in degree mode, you will not get the correct answer. So 8 times sine 37, and let's round to the nearest hundredth, which is 2 places. I'm going to have A is equal to 4.81. Regrouping, I'm now going to go back to the triangle and say, how can I figure out B? And I'm still going to use the 37. Just for validity, there are other ways to solve this. So if your brain or your eyesight is drawn to something else, try it. Make sure that you get the same answer. And if you are a little wary about whether or not your method would work or the way that you chose to solve it would work, ask. So this time I'm going to use cosine. So I have cosine of 37 is equal to B over 8. Similarly, I'm going to multiply both sides by the 8, putting that into my calculator. So I've got 8 cosine this time, 37. So I get that B is equal to 6.39 when I round to the nearest hundredth. So now I have solved for all of the missing parts of the right triangle. Okay, so now let's apply it a little bit. So we are going to find the height of this building. So I have a right triangle here. So as soon as you see right triangle, our brains need to immediately go to the trig place. The angle that they tell us in this picture is 65, and then the distance from the edge of the building to the end of the triangle is 340 feet. We are looking for this height. So if I label the triangle based off of the angle that we know, my hypotenuse is always across from the 90 degrees. The question mark is going to be my opposite, since it's on the opposite side of the 65, and 340 is adjacent. So now we have to consider the pieces that we have and how we're going to use this to solve. So we need the opposite and we're going to need the adjacent, because the opposite is the question mark. It's what we're actually looking for, and 340 is an integer that I can use. So I'm using opposite and adjacent, so that's going to be tangent. So I have tan of 65 is equal to, I'm going to use x because that's what we use in math when we don't know what something is, over 340. So now I need to multiply both sides by that 340. So when I compute that in my calculator, I get that the height of the building, 729.13 feet.